First, let's go over the immune system. There are 5 types of immune system cells. We'll only just be talking about the lymphocytic cells, which contain the T cells and the B cells. B cells are mainly responsible for antigen production and labeling the pathogens as they enter the body. T cells, there are a lot of T cells. Helper T cells, which are also called CD4 cells because of their surface protein. These cells trigger cytotoxic killer T cells to destroy invading pathogens. The cytotoxic killer T cells, like I said, they destroy invading pathogens by basically engulfing them, then destroying them as they're inside them. Regulatory cells monitor the killer cells, basically regulating them in the name. They stop the killer T cells just in case there's an autoimmune response, in which case the cytotoxic cells are killing the body cells, which is killing the host. This isn't good. Memory cells remember antigens, which are presented by the B cells. This helps your immune memory, which means that if you got a virus or a disease before, you'll remember how to defeat it. These cells come together to form most of the immune system. Memory T cells recognize invaders from previous knowledge, such as immunizations or previous cases of the disease, and in turn they trigger the B cells to release antigens that tag the bacteria as invaders. The B cells that release this antigen then present it to the T helper cells. They bind to the TCR CD3 complex and the CD4 complex as well, these bring the cells closest together so that the T helper cell can recognize the antigen and the invading pathogen, and in turn it recognizes the pathogen by analyzing the antigen. This is a quick picture showing exactly how the T helper cell binds to the B cell and responds to it. As you can see, it's quite a long process, so I won't bother explaining most of it. What you really need to know is that the T helper cell verifies that the B cell has an actual antigen, and then side-checks the antigen to make sure what disease it codes for, and then it sends the cytotoxic killer cells after it. Now let's move on to HIV. HIV is a sexually transmitted disease that once inside the host's body, binds to the T helper cells through the CD4 receptors. Once it's attached to the CD4 receptors, it's engulfed into the cell through endocytosis. Once it enters the cell, it releases its RNA material and an important enzyme called reverse transcriptase. This enzyme is capable of making DNA from a single strand of RNA, allowing the cell's protein manufacturing processes to be hijacked by this virus. Once the virus is in the cell, it then makes replicas of itself, which leaves the cell by budding off of it. This allows the HIV virus to have the same receptors as the cell invaded, allowing it to invade other cells of the same type, namely the T helper cells. Unlike most viruses, HIV doesn't directly kill the T helper cell. The T helper cell kills itself, actually. Once it recognizes the growing presence of foreign protein inside of its cell, it triggers its own apoptosis in an effort to protect the host cell from more viruses. When T helper cells die, they trigger inflammation, a signal that something is wrong in the body. This inflammation, in turn, triggers more helper cells to go to the site of the infection. Once they arrive at the site of infection, though, HIV is already multiplied 1,000-fold because of the amplification it got from being inside the T helper cell. And in turn, all this HIV infects the T helper cells that are arriving at the site of inflammation, in turn causing more inflammation to occur. This vicious cycle is why so many T helper cells are killed off so quickly. Although T helper cells are killed off in exuberant numbers due to their own apoptosis as a result of the HIV infection, the immune system eventually catches on and suppresses the HIV. The HIV then has no choice but to lay low and won't kill any T helper cells for a while. This period is called clinical latency, where the T helper cell is essentially non-active. However, it accumulates its numbers and spreads throughout all parts of the body. At this one point, the HIV virus then starts killing the T helper cells once more, in a sudden spike of HIV activity and a sudden decline of CD4 cell count. This inevitably causes invading pathogens to become more effective in their killing of your body, so people may be able to die of the common cold or even the flu. After the period of clinical latency, T helper cells drop quickly. In a normal human body, free of HIV, perfectly healthy, a normal T helper cell count is about 500 to 1600 cells per millimeter squared of blood, per cubic millimeter of blood. This is The high numbers may be for when you're experiencing a mild infection, low numbers are when you're perfectly healthy. However, after the infection of HIV, after the period of clinical latency where HIV activity spikes dramatically and continues to stay that way, T helper cell levels drop to only 200 cells per millimeter squared. 500 is the base number if you're perfectly healthy, but even if you're experiencing a disease, in which case T helper cells grow quickly to 1600 cells per millimeter squared, you only remain at 200. And as I might have said before, the T helper cells recognize the presented antigen and then direct the killer cells to destroy the invading bacteria. Without this form of cell to direct the killer cell, nothing really happens. The pathogens that are invading your body to try to kill you, they're left unchecked, so you may die of the common cold if you get this. This condition is called autoimmunodeficiency syndrome, also known as AIDS. This is directly caused by HIV. In conclusion, I hope that you have found out how HIV disrupts the cell signaling process of the immune system. In case you haven't, I'll explain it for you. HIV takes out the T helper cell from the equation of this immune system, making a block between the signaling and the response. Although the B helper cells and the memory cells may recognize and tag the invader, nothing they can do will cause the invader to be killed by the cytotoxic killer cell. So, as a result, you inevitably die because you can't do anything to fight off viruses. And that is what HIV wanted, is how it kills you. And that is my conclusion. I hope it was yours too. Thank you for watching.